So today we're going to solve radical equation word problems. So the question is, how do you solve a radical application problem? Well, we're going to use our formulas to do that. So first I want you guys to remember that x to the 1/2 is the same as the square root of x. Remember that can be indicated with an index of 2, but most of the time is indicated without the index like it is up here. And then we have x to the 1/3 is the same thing as the cube root of x. So on our warm up here, I'd like you guys to go ahead and work this problem and then come back to me when you're done. But I want to show you something before you do that. So I just talked about how 1/2 was the same as the square root. So here's the thing. If you guys are more comfortable writing this problem as a square root, then I would do that if I were y'all. So you could start out the problem like this and go ahead and just write it as a square root, since you might be a little more comfortable working the problem this way. So go ahead and work this problem, pause the video, come back to me when you're done. All right, so our next step would be to square both sides of this. That would give us 2x plus 15 equals x squared. The subsequent step would be to move this stuff. So we would subtract the 2x from both sides, and we would subtract the 15 from both sides. That would give us 0 over here, and x squared minus 2x minus 15. So then what we need to do is we need to factor this. So we got 0 equals here. We're going to put 2 sets of parentheses. And so the question we need to ask ourselves is what are the factors of negative 15 that add up to be negative 2? So that would be plus 3 and minus 5, right? So then we need to set each of these equal to 0 and solve them. So this would be x is equal to negative 3, and this would be x is equal to 5, because we're going to subtract 3 from both sides there and add 5 to both sides there. So now what we want to do is check these. Remember that we have to check these to make sure that they work in the equation. So we're going to do that next. So down here we're going to do the square root of 2 times negative 3 plus 15, and we're going to see, does that equal negative 3? So this is going to give us the square root of negative 6 plus 15. Again, does that equal to negative 3? This is going to be the square root of 9. And the square root of 9 is 3. And 3 does not equal negative 3. So this would not be a valid solution. So this would be our extraneous solution. Okay, so then we need to test this 5. So we're going to do, again, the square root of 2 times 5 plus 15 and see if that equals 5. So that's going to be the square root of 10 plus 15. So that's the square root of 25. Well, the square root of 25 is 5, so 5 does equal 5. So this is our valid solution. So again, on this next problem, you can do it with the 1/3, or again, you can make a cube root. It doesn't matter which way you do it. You just got to know that the opposite of 1/3 is 3. So when we're trying to get rid of it, we're going to cube it. So I'm going to go, again, write this as a cube root, so some of y'all feel more comfortable doing it this way, and it doesn't really matter which way you guys do it. So, but I do want you guys to, again, pause here, go ahead and work the problem, and come back to me when you're done. So my next step here is going to be to divide by 3, because that 3 is being multiplied. So that's going to give me the cube root of x plus 5 is equal to 3. And then our next step, obviously, since this is a cube root, would be, it's a 5, y'all. Whoa, let me make that a clearer. Sorry. X plus 5. Okay. So we're going to cube both sides of this, because when we do that, that cancels out that. So we're left with x plus 5. And 3 times 3 is 9 times 3 is 27. So then we're going to subtract 5 from both sides. So x is equal to 22. And again, I'm going to check this because I don't like getting things wrong. So I'm going to do 3 times 22 plus 5 to the 1/3 power. And we would typically put that in the calculator as the 1/3 power as well. So go ahead and do 27 to the 1/3. And you should see that that's 3. So 3 times 3. Yep, that's 9. So 9 equals 9. So that is our answer. And remember, with the cube root, you are not going to have extraneous solutions. All right, so here's our application problem, or word problem. So the speed in miles per hour that a car is traveling when it goes into a skid can be estimated by the formula S equals square root of 30 FD, where F is the coefficient of friction and D is the length of the skid marks in feet. So I'm going to go ahead and rewrite that formula for us. S equals the square root of 30 FD. So I want to find which variables we have here. So it says F is the coefficient of friction, and here it says the coefficient of friction is 0.7. So F equals 0.7. And then it says D is the length of skid marks, and down here it says the skid marks are 120 feet, so D equals 120. So we're going to do S is 30 times 0.7 times 120. And then we're going to solve for S. So that's going to be, when we multiply those three numbers together, it gives us 2520. And then we take the square root of that. It's going to be 50, where's my notes, 0.2 miles per hour. So my question for you guys is, did I answer the question? It says if the speed limit is 45 miles per hour where a car goes into a skid, the coefficient of friction is set 0.7, the skid is 120 feet. Was the driver speeding? So here's our question right here, y'all. Was the driver speeding? That's the question. If the speed limit's 45 miles per hour, right? So the answer is yes. That's actually the answer to the question. Now we had to solve the 50.2 miles per hour to get that answer, but that's the answer. All right, let's go on to this part B. It says, again, the beginning part of it is how fast was the car traveling? So this time S equals, again, the square root of 30. Our friction is 0.7 again, and our distance that it skidded was 35 feet this time. So when we do this, this is going to be the square root of 735. And then when we do that, that equals 27.1 miles per hour. This time it did ask us how fast, right? Okay, so the next one. On y'all's notes, it says here, on a clear day at sea, the approximate distance d in miles that a person can see is given by 1.2116 times the square root of h, where h is the person's height in feet above the ocean, right? So it says, how far can the captain of the ship see when he is on deck? So again, I'm going to say d equals 1.2116 times the square root of h, and we know h is equal to 15. So we're going to go ahead and solve for this. So this is 1.2116 times the square root of 15. You guys can put that right in your calculator. And when you do that, it's going to tell you 4.7 miles, right? And yes, it's miles because it says D in miles up here, okay? Then we're going to go on to part B. It says, how much further can the sailor in the crow's nest 120 feet above the water see? Okay. So, we are going to, for this problem, again, use D equals 1.2116. This time h is 120, right? So the distance here is going to be 13.3 miles. Now, here's the thing. The problem asks us how much further. So we have to take that 13.3 and we have to subtract from it that 4.7. And when we do that, we get 8.6 miles. Okay, now let's go on to part C. It says if a pirate ship is sailing toward them at 10 miles per hour, how much sooner will the sailor see it than the captain? So the pirate ship was the second ship that we saw, where the sailor was in the crow's nest, right? Okay, so this time we've got D equals speed times time, right? So we want to solve for what? Pirate ship sailing towards them at 10 miles. How much sooner? So that's time, isn't it, y'all? So let's go ahead and solve this for time. So that means time is going to be equal to distance over speed, right? So our distance we had in our last problem, so that was going to be 8.6, and then our speed is 10 miles per hour. So when we do that, we're going to get 0.86 hours, right? Well, I don't know about y'all, but I don't have a clue how much time that is. So I need to figure out how many minutes away that ship is, right? So I'm going to multiply that 0.86 times 60 minutes, right? Because that's hours, and I want it in minutes, and there's 60 minutes in an hour. So when I do that, that's 51.6 minutes. And just so you guys know, we could actually convert this to minutes and seconds by doing the 0.6 times 60 as well, and that would give us our seconds.